Hi everyone, just wanted to take a minute to talk a little bit about the surface area and volume of spheres. So a sphere is kind of like the three-dimensional version of a circle. So it is the set of all points in space that are going to be equidistant from a given point, which we are calling the center. Okay. As always, it has a radius, which is going to be from the center to any point on that sphere, all the way across would be the diameter. You'll frequently kind of see this circle drawn. So any circle in the sphere that contains the radius, or I shouldn't say a radius of the sphere, is something known as a great circle. So if you ever happen to see the word great circle, it really just is talking about um, a circle with a diameter that is equal to the diameter of the sphere. Uh, and you're probably looking at me like, well, why wouldn't it? Because it is possible to make like a circle right over here or something like that. That wouldn't have a diameter equal to the diameter of the sphere. So if you ever see great circle, that's all it means. It's just like if you cut through the middle. Okay. Now, since we are dealing with surface area and volume, we do have to worry about the formulas. Again, just like with the cone and the cylinder and things like that, a lot of the cone in particular, we're not really going to talk about where these formulas come from, but they are kind of derivable using kind of knowledge of circles. And you can kind of look them up. We didn't really focus a lot on circles yet, so we're not going to focus on them for right now. In terms of surface area, it is 4 times the area of the circle, if you will. Um, and again, the formulas are derivable. We're just not going to focus on them for right now. The volume is going to be 4/3 pi r cubed. So you got to be careful. This is one of the situations where you do have something that is being cubed. One other piece of information, much in the way that a semicircle is half of a circle, if you cut a sphere in half, you get a hemisphere. Hemi and semi are both kind of prefixes meaning half. Um, the H's and the S's frequently kind of get interchanged, like septagon and heptagon and things like that. But so a hemisphere is half of a sphere. So all you end up just doing is dividing by 2, which is why the volume is 2/3 and the surface area is now 2 instead of 4. Okay, so just keep that in mind. All right, so for example, to find the surface area and volume, we need to make sure we know our formulas. So our surface area, right, that is 4 pi r squared, and our volume is 4/3 pi r cubed. Okay, over here we've just cut it in half because this is a hemisphere. So it'd be 2 pi r squared, and the volume is going to be 2/3 pi r cubed, right? We're just dividing by 2 because 4 divided by 2 is 2. 4/3 divided by 2 is 2/3. So let's plug in. Okay, so surface area. All right. 4 pi. Remember, it's 99. It's 89 over 2 squared. Okay, I don't know what 89 squared is, but I know 2 squared is 4, which cancels very nicely with that 4. So 4 pi, what is 89 squared? Oh, it's not even on. 7,921 over 4. The 4's cancel, so that just leaves you with 7,921 pi feet squared. Okay, there's your surface area, and your volume is going to be 4/3 pi, again, still the 89 over 2, cubed. Okay, I don't know what 89 cubed is. Oh, 704,000. Now that doesn't, I don't know if it is divisible by 3, but it looks like it's divisible by 3. Let me just check that. Oh, no, guess not. Okay, never mind. times 4/3 over 2 to the third is 8 times pi. Okay, so we simplify that. That actually doesn't really cancel much. Well, that will. So that's a 2. Okay, so 7,04969 over 6 pi feet cubed. Okay, so unfortunately these do get to be big numbers, but that's okay. Now, over here we have the hemisphere. So let's start with surface area. So 2 pi r squared. Remember, the radius would be 16, so half of it. So 16 squared, and 16 squared, don't forget, is 256. That is that is a common one. Yes, you just saw me look over because I sometimes screw it up. I always want to say 216 for some reason. Anyway, it is 256. All right. So that is 512 pi meters squared. Okay, and I appear to have run out of room. But wait, I can fit it in. So the volume then would be 2/3 pi 16 cubed. With 4096. Okay, so the one thing I will say is I do know for a fact that that's not going to be divisible by 3 because the only powers of, okay, so like 16 is just 2 to the third. So when you're dealing with 16 and powers of it, you know you really only have 2's in the, if you were to factor it out, so the 3 is never going to cancel. So when you multiply that by 2, let's see, what do we get? Oh, I'm going to run out of room. Let me move. Okay, so when we multiply that by 2, we have 8,192 over 3 times pi. And that doesn't simplify, so we're going to leave that as is with meters cubed. And sorry, I kind of ran out of room there. But ultimately, as you can see, it is just kind of in that case, a situation of dealing with a lot of 2's. You can kind of do this out by hand. You saw me checking it just because I didn't want to keep restarting in case I accidentally made a mistake. But ultimately, just know it's a lot of the numbers. If you can simplify. It usually will make things easier. All right, let me know if you have any questions and have a great day.